Welcome to 8.3. In 8.3 we see one of the main reasons why we defined the complex numbers in their polar forms. So we have this polar form of a complex number, which is r, let me get a pen here, which is r cosine theta plus I sine theta, right, with that r on the outside. Could be distributed through as you need to, but that's our polar form of a complex number, of that complex number that in a rectangular form would be a plus bi. So we're like, well, why even do that? Well, it makes some products and also some powers especially easy to do. It'd be hard to do in its rectangular form, or at least long to do. And so we want to trade out for its polar form. And so what we have here is we're going to derive the product and quotient theorems, right? The product and quotient formulas, for lack of a better way to say that. And so those are below, and you could see them if you have your notes open. But we need to show you how they're derived so you don't think that we're hand waving or anything like that. But for time's sake, I'll only do the product because the quotient will be very similar. So let's talk for a moment. In order to help ourselves isolate stuff, I'm going to have Z1 represented in blue, and I'm going to have Z2 represented in red. So Z1 times Z2 is this. Go blue. Z1, R1 cosine theta 1 plus I sine theta 1. And Z2 is R2 cosine theta 2 plus I sine theta 2. And we just need to multiply those together. So what I do know is that we can bring out our R1 and R2. So it's going to be a lot of back and forth with colors, but I think it will help you to track everything because it's very hard to deal with the subscripted numbers. So this is what I'm just trying to do, one thing at a time here, and ideally capturing everyone. And so the only thing that happened in this step was bringing the r's out in front. And they're going to stay there forever. Okay, so I'm actually going to put those in black as I go to rewrite this stuff because they're locked in. Those are going to be part of our end answer. So now what do we have? Well, we got to multiply some things together. And so what do? We do FOIL. There's 4 terms there. We're going to do FOIL. So we're going to have cosine theta 1 times cosine theta 2. And then plus, and then we're going to have, I'll stick with distributing through the cosine theta 1 times I sine theta 2. Okay, we have 2 other terms to write. Hopefully I can fit them in here. Plus, in blue, I sine theta 1 times cosine theta 2. And then plus, and one last one, I sine theta 1 times I sine theta 2. Okay, and let me do one other thing that was bothering me. That parenthesis I'm just going to make black. There we go. So let's clean up a little bit. What do we got? Let's take and put our eyes together. They are together in the middle. So let's talk about something. This right here, let me highlight it. These eyes, when multiplied together, will produce I squared, which we know is negative 1. So what do we have right now? We have R1, R2, and we have cosine theta 1 times cosine theta 2. Now I'm going to bring that last term to it. The I squared is going to be a negative 1. So we're going to get minus. And what do we have there? We have sine theta 1 times sine theta 2. And then we have a plus symbol. Everything else is plus. And I'm going to factor the i's out of it. And what do we have? We have, I'll put it in order as it appears, sine theta 2. Well, actually, that isn't the order in which it appears. So let me be careful there. I almost forgot the cosine, right? So cosine theta 1, sine theta 2, plus sine theta 1 cosine theta 2. Awesome. Well, look what we have. Take a look at these guys right here. Okay, so how about this first one? Do you recognize that? Sure you do. That's the cosine. Actually, let me put it in black because it's no longer. That you recognize that from your identities. That guy right there is cosine theta 1 plus theta 2. Remember, that's cosine minus sine. Perfect. And what's this one right here? Alternating, same positive sign in the middle, but different ones. This is the sine of theta 1 plus theta 2. And it's an I. So what do we have? We have R1, R2 times the addition of the two angles cosigned and the sine of the two angles cosigned. And so that's what's down here. And something similar would happen with the division. So the big compact, here it is in its big form, that R1 cosine theta 1 plus I sine theta 1 times R2 cosine theta 2 plus I sine theta 2 is as simple as multiplying the R's and adding the angles, and you're done, right? And there it is in its compact form. So quotient shouldn't surprise you. Instead of adding, we would subtract. So lots of connections between exponent rules as well, which is super cool, right? There's a lot of fluidity in math. So how are they going to get us to know this? They're going to ask us to use it. So when you multiply the magnitudes and add the angles. And when you divide the magnitudes and subtract the angles. So let's go watch that happen. So here's some examples closely tied to the homework. And what do? Well, we got a product going on here. So we do 8 times 2, no problem, 16. And then you know what it is. It's going to be cosine I sine. So you could use the shortened notation if you want. You could keep it big. I'll keep it big since they did it here. But there's your 16. Cosine of 210 plus 330. Well, that's 540 degrees. Plus I sine of 540 degrees. So now where are we? We're back to chapter 1 where they're talking to us about angles, saying where's 540 degrees? Well, 360 plus 180. So here's 360. Oh, sorry, there's 360. And then if you go 180 more, that's where 540 degrees is. So if we know the cosine of 180 and the sine of 180, we're done. And I think we do. 16 cosine of 180 degrees is -1 by memorization, plus I sine of 180 degrees is absolutely 0. And so what do we get out of this? A real number, -16. So these two imaginary numbers multiplied together gave us a real number of -16. Pretty cool. So what's going to happen over here with number 12? 3 times 7, no problem, 21. They choose to use the shortened notation, right? And notice that they're bouncing us back and forth between the notations, which is great. Again, you're welcome to use whatever you want. 300 and 270 is 570. So then we have to ask ourselves, well, where's 570? Well, 570, we just found out 540 was right there. So 570 is 30 degrees reference angle in that third quadrant. No problem. So that's 21. And they want us to write it in rectangular form. That's why we're doing more work, right? Because we need it in rectangular form. So I got to think about 30 degrees. The cosine of 30 degrees is root 3 over 2. But it'll be negative because it's in the third quadrant. And the sine of 30 degrees is 1/2. But it will also be negative because it's in the third quadrant. So look at all the good math that's coming through. The good stuff from the very beginning of the class. What's a reference angle? What's the cosine, sine of, and tangent of all the, in this case, just cosine and sine of all the special angles? If we stay with the special angles. Again, if you're doing this and you don't have memorized root 3 over 2, you are going to have a hard time in future classes. Don't do that to yourself. And here it is in its rectangular form with the 21 distributed. That shows both the real and the imaginary part. Awesome. And how about number 16? We're going to do a division. 12 divided by 6, 2. Now, remember, it was a subtraction of the angles and the order matters. So 23 minus 293. So I'll do 2 CIS. Let me remove that parenthesis. I was going to do it the same way, but let me just use the shortened notation because of this space here. You're going to get negative 270 degrees. Well, where's negative 270 degrees? I think you know where that is. That's right there. It's at a 90-degree angle. So what's the cosine of 90 degrees? Well, that's 0. And what's the sine of 90 degrees? Well, that's 1. So what are we looking at? We're looking at 2i. No problem. Somebody might be able to just say that it was 2i without going through all this by saying, hey, we're ending up here. The magnitude's 2. Oh, it's 2i. Right? We're ending up over here on this flat 180 line. The magnitude's 16. So what is that? Well, it's the real number, negative 16. So it makes sense where we're ending up and what we're finding. What they want us to practice with in these next ones, I went and looked at the homework. They want you to translate these guys into their polar form. Sorry, I dropped the word. And then do the work. So they do not want you to do what you would do back in Math 120, or I'm sorry, intermediate algebra or before. They don't want you to rationalize the denominator and come up with it that way. They would rather you work with the translation. So the first thing that we need to do is translate these into their ones. And so you know where 2i sits. 2i sits right here. So what's 2i? It's 2 CIS 90 degrees. Now, how about negative 1 minus root 3i? Well, we got to go work on that one. So where do we get our practice with this? In earlier sections. So if on the exam I have a problem like this and the wording is translate each into their polar form and then do the work, you must do it that way. If you do it by the rectangular way, you're missing out on an opportunity to practice in a small problem and you'll miss the problem. Okay, I know that you can do it because you passed intermediate algebra the rectangular way. The question is, can you do it the trigonometric way? And so where is negative 1 minus I root 3? It's important for us to know that. Well, it's right down here, right, where we're going. This was the so this is negative 1 to the left and negative root 3 down. And so what angle is that? Well, I got to think about that. It's 180 degrees. And what would have this relationship right here? Where we would have the 2 here, right? So the magnitude's definitely 2. Do you see that? That negative 1 squared plus negative root 3 squared needs to be equal to r squared, or 1 plus 3, it needs to be r squared, so r is equal to 2. So we knew that was 2. So the question is whose sine is root 3 over 2? 60 degrees. So it's a 60-degree reference angle, so this is 2 CIS 240 degrees. And we need that degree measurement in there. Awesome. So where are we? We're right back to where we were with the other problem. So this whole section is all about practice converting again, and then practice doing work. So remember, these two things are stacked. So maybe I can just come in here and draw my lines here. So there's a translation of them. 2 divided by 2 is 1. And so we have 1 CIS. 90 minus 240 is negative 150 degrees. perfect. We just need to figure out where negative 150 degrees is. And it's right here, 30 degrees off of that. So what's its cosine? Cosine of 30 degrees is root 3 over 2, and it will be negative. Sine will also be negative, and it's going to be the 1/2. And we're done. We get the exact same answer that we got in a previous problem somewhere. Seems like we had gotten that before. Oh yeah, we did it with this 21, right? When we had 570, we ended up in the exact same place with the 570 as we did with the negative 150. But that's what the problems feel like. So here we're going to have to do the same thing. It's a two-step process, and it's actually a little bit cleaner than if you did it the other way. But that's a matter of personal choice. They're not allowing us to do it the other way. They want us to do it through the trig. And so let's take this one and let's figure out what we have. Where are we? Well, we're negative and then positive, so we're out here. We're in quadrant 2. Awesome. So what do we have? We're going over negative 3 root 2 in the real direction and up 3 root 6 in the y direction. So the question is, what's this length up here of the hypotenuse? No problem. So what do? We take 3 root 6 and square it, plus negative 3 root 2 and square it, and that's got to be equal to r squared. Well, 9 times 6 is 54, plus 9 times 2 is 18, is equal to r squared. And so we get 72 is equal to r squared. So r is equal to, I guess that would be 6 root 2. Yeah, it's 36 doubled. So 6 root 2. Sorry for the hesitation there. And doubted myself. So hopefully you're good with where the 54 and the 18 are coming from. Just your core math from back in pre-algebra. How to square roots. 3 squared is 9. Root 6 squared is 6. 9 times 6 is 54. Negative 3 squared is 9. Root 2 squared is 2. 9 times 2 is 18. So this is 6 root... Whoops, I'm still in the eraser mode, sorry. Let me go put that back. And this is 6 root 2. Awesome. So we need that. Now what angle are we dealing with? If I stack those, I get 3 root 6. Well, let's look at who's sine. Let's look at sine. Sine theta would need to be 3 root 6 over 6 root 2. So that would be yeah, or I could just look at the ratio there. So that would be root 3 over 2. Yeah, sorry. So I get a root 3 over 2. So you could look through sine. I don't know why I went to sine. It could have done tangent. Could have done cosine too. You just need one relationship. Where are we? First exam. Trying to figure out what angle we're looking at. The angle that we're looking at is a 60-degree angle, right, in that quadrant. And so 60 degrees back from 180 is 120. Perfect. So what do we have? With this top one translated down, or translated over, I'll put it in blue, is 6 root 2 times CIS of 120 degrees, right? Cosine I sine. Now we got to do the same thing for the bottom. So how about the bottom's magnitude? So if we come back to black and we do that work down here, it's root 6 squared plus root 2 squared, which is 6 plus 2, well that's equal to r squared, is equal to r squared. 8 is equal to r squared, so we got a 2 root 2 is equal to r. And so we have a nice 2 root 2 under here. I'll put that in blue. And the question is, what's our angle? Well, where are we? We're in the first quadrant, right? Both are positive. So let's go ahead and draw that out. Makes every difference that you know what quadrant you're in. Don't just do these by stacking numbers. So root 6, root 2. So root 6 in the real direction, root 2 in the imaginary direction. And this is 8. So the tangent, I'll do tangent this time, is root 2 over root 6, which is equal to 1 over root 3. And so who's that? I think that's a 30-degree angle, right? The 30-degree angle is that guy. So theta is 30 degrees. Perfect. This is CIS 30 degrees. So we did all that work, right? We're doing the practice there, so you can see how I can double up on some stuff as I ask questions on the exam and have you show me that you know how to convert to polar form, and then also work with polar form within the same question. 6 divided by 2 is 3. Root 2 divided by root 2 is 1. CIS 120 minus 30 is 90 degrees. Well, that's 3i then. Do you see that happening in multiple ways? Where is 90 degrees? Right here. You're only going in the imaginary direction and your magnitude's 3. It's got to be 3i. Cosine of 90 degrees, 0. Sine of 90 degrees, 1. So cosine plus I sine would yield 0 plus 1i, which is I, and that's 3i. So lots of ways to verify that. So these are good representations of the homework that you're going to see as you travel through this 8.3 section, getting familiar with the product and quotient rules that are there, but really honing your skills working with the polar form of a complex number. So the next section is the most important one, and that's de Moivre's theorem and finding nth roots using a de Moivre type of idea. And so that's where we really need this polar form. It's not necessarily for products and quotients, but it lays the foundation for what's needed for powers and roots.